personally salute all frontliners who have worked tirelessly and innovators who have yielded a solution to prevent and treat COVID-19 and other crisis situations, or an initiative which has contributed towards mitigating the impacts of coronavirus and providing relief to communities. I have observed abundant creativity and innovation emerging at the national, institutional, organizational, and individual levels for the past year.
Now is the ideal time for initiatives like this to be explored, not only encourage development of innovation, but to manage future emergencies and crises.
Sejak mencapai kemerdekaan, Malaysia telah mengalami transformasi yang pesat demi kemakmuran dan kesejahteraan rakyat. Sektor kesihatan, antara sektor terpenting negara, sentiasa berhadapan dengan pelbagai isu dan cabaran dalam era globalisasi ini. Fokus Kementerian Kesihatan menjadi lebih luas, terutamanya dalam menyediakan kemudahan kesihatan yang saksama, mudah diperolehi dan berkualiti. Untuk itu, perancangan dan pelaksanaan program kesihatan negara perlulah berasaskan kepada bukti saintifik menerusi hasil-hasil penyelidikan yang berkualiti. Penubuhan Institut Kesihatan Negara atau NIH yang bernaung di bawah Program Penyelidikan dan Sokongan Teknikal Kementerian Kesihatan Malaysia adalah bertujuan untuk menjalankan penyelidikan yang mana hasilnya dapat memberi bukti saintifik terhadap pembentukan polisi dan intervensi bidang kesihatan. NIH telah diluluskan di bawah rancangan Malaysia ke-7 dan secara rasmi beroperasi sejak bulan Ogos 2003. Visi NIH adalah untuk menjadi organisasi penyelidikan kesihatan terkemuka ke arah meningkatkan kesihatan dan kesejahteraan negara. Manakala misi NIH adalah menjalankan penyelidikan, latihan dan perundingan berkaitan kesihatan yang berkesan dan berimpak tinggi untuk meningkatkan kualiti hidup. Selain itu, NIH juga bertanggungjawab untuk mentadbir dan menguruskan penyelidikan di negara ini untuk menangani isu-isu kesihatan nasional. Kompleks NIH seluas 40 ekar di Setia Alam Selangor mempunyai ciri-ciri seni bina moden yang melambangkan kerancakan transformasi perkhidmatan kesihatan yang dizahirkan oleh penyelidikan yang berkualiti tinggi. Dilengkapi dengan pelbagai fasiliti serba moden, NIH turut menekankan kepentingan ekosistem alam sekitar yang mampu mewujudkan suasana kondusif untuk penyelidikan. Kompleks NIH menempatkan sebanyak 6 buah institut yang mempunyai pengkhususan dalam bidang penyelidikan masing-masing. Kelancaran operasi setiap institut ini disokong oleh pejabat pengurus dan pejabat pendaftar yang menjadi tunjang utama dalam pengurusan strategik dan pentadbiran NIH. Institut Penyelidikan Perubatan atau IMR merupakan institut penyelidikan biomedical tertua di Malaysia yang diwujudkan sejak tahun 1900 oleh Kerajaan British. Ketika itu, ia dikenali sebagai Institut Pathology di Kuala Lumpur. Hasil penyelidikan IMR telah banyak menyumbang kepada pengetahuan, pemahaman, rawatan dan kawalan beberapa penyakit tropika utama di negara ini dan rantau Asia Tenggara. Kini, fokus IMR juga kepada penyelidikan bioperubatan seiring dengan trend perubahan isu dan beban kesihatan negara serta kemajuan teknologi perubatan. Sejarah Institut Kesihatan Umum IKU bermula di Singapura sebagai Royal Sanitary Institute dan dijenamakan sebagai Royal Society for Promotion of Health RSH yang berperanan melatih inspektor kesihatan dari Tanah Melayu, Singapura dan Borneo. IKU berkembang menjadi pusat penyelidikan epidemiologi dan kesihatan awam yang menyediakan data-data kesihatan penting pembuat dasar dan pihak berkepentingan mengenai prevalen penyakit dan taraf kesihatan rakyat negara ini. Antaranya adalah tinjauan kebangsaan kesihatan dan morbidity at National Health Morbidity Survey yang dijalankan secara berkala. Institut Penyelidikan Klinikal atau ICR berfungsi sebagai cabang penyelidikan klinikal KKM dan mula beroperasi sejak Ogos 2000. Dengan 5 buah pusat kajian yang berperanan menggerakkan kajian-kajian klinikal tersendiri serta mempunyai 36 cawangan di hospital-hospital utama KKM di seluruh negara. ICR memainkan peranan penting dalam menerajui pembangunan dan pengukuhan kapasiti penyelidikan klinikal negara, mewujudkan dan mengekalkan pengkalan data klinikal bagi KKM dan juga mewujudkan kerjasama dengan organisasi penyelidikan tempatan, serantau dan antarabangsa mengenai penyelidikan klinikal. Institut Penyelidikan Sistem Kesihatan atau IHSR ditubuhkan pada November 2002 bagi membantu KKM dalam pelaksanaan penyelidikan terhadap sistem dan pengurusan kesihatan negara yang membantu dalam menyediakan bukti saintifik kepada pengubal dasar dan polisi kesihatan negara mengenai taraf dan kualiti penyampaian perkhidmatan kesihatan kepada rakyat. Institut ini berperanan dalam melaksanakan penyelidikan berimpak tinggi dalam bidang penyampaian perkhidmatan kesihatan negara, melaksanakan penilaian terhadap dasar dan polisi kesihatan dan kebolehcapaian perkhidmatan yang saksama dan berkualiti dalam kalangan semua rakyat negara ini. IHSR telah mendapat pengiktirafan antarabangsa dan telah dilantik sebagai Pusat Kerjasama Serantau WHO untuk peningkatan kualiti dan kesihatan. Institut Pengurusan Kesihatan IHM bermula di bawah Institut Kesihatan Awam yang dikenali sebagai bahagian latihan pengurusan. Penubuhan IHM bermula pada rancangan Malaysia ke-6 yang mana ia bertanggungjawab dalam meningkatkan pembangunan modal insan profesional di KKM untuk menghadapi cabaran dalam penyampaian perkhidmatan kesihatan yang berkualiti. Bidang penyelidikan yang dipelopori oleh IHM ialah aspek kepuasan pelanggan, pengurusan sumber manusia serta pemantauan dan penilaian terhadap kualiti perkhidmatan kesihatan negara. Selain itu, IHM turut berperanan sebagai sebuah institut yang menyediakan latihan berkualiti tinggi kepada kaki tangan KKM. Institut Penyelidikan Tingkah Laku Kesihatan IPTK ditubuhkan pada 2005 adalah bukti bahawa bidang tingkah laku kesihatan adalah penting dalam usaha mencapai sebuah negara maju. IPTK bertanggungjawab dalam melaksanakan penyelidikan inovatif dalam bidang tingkah laku, penilaian intervensi promosi kesihatan, kaedah komunikasi kesihatan yang efektif dan komunikasi risiko. Penyelidikan yang dilaksanakan oleh penyelidik-penyelidik di NIH bukan sahaja telah memperbaiki penyampaian kesihatan kepada rakyat Malaysia, namun telah turut mendapat pengiktirafan di dalam negara dan di peringkat antarabangsa. Way Forward NIH akan terus mengkaji dan meningkatkan kepakaran para penyelidik ke arah menghasilkan kajian-kajian berkualiti dan berimpak tinggi dalam meningkatkan taraf kesihatan dan kehidupan rakyat Malaysia.
Wonder how fast intelligent machines run on 5G? At MMU, you'll find the answer. Wonder how creative content and online businesses are mastered? At MMU, you'll find the answer. Wonder how cybersecurity and law function? At MMU, you'll find the answer. Find out all these and many more at Multimedia University, because MMU is you, leading the digital future. Visit mmu.edu.my.
Ladies and gentlemen, our next lined up program is a knowledge sharing session. Please enjoy.
Hello, a very good day to every one of you. First of all, I would like to thank the organizer for giving me this opportunity to share my little experience about COVID-19 vaccine supply and demand modeling in Malaysia. And I'm going to share what is behind the scenes in the optimization, forecasting, and modeling work that I have done. Okay, without further delay, let's move on together. Before I share my experience, allow me to thank the government of Malaysia, particularly MOSTI and Academy Science Malaysia, for giving me the opportunity to involve in the national vaccination program last year. A bit introduction about myself. My name is Ting Chui. My academic qualification is PhD in IT, and I've been specializing in machine learning for the past 10 plus years. And currently I'm a professor at the Faculty of Computing and Informatics, Multimedia University, Cyberjaya. Before I begin with the core discussion about the modeling work, about the vaccine supply and modeling, allow me to have one slide about data science so that we have the same idea together. Now, data science is basically a study of data systems and processes. Well, it uses a combination of tools, application, principles, and algorithms to make sense of random data cluster. So they are random data coming in, and inherently there are a lot of undiscovered clusters. Now, data science focuses on data modeling to track the ever-growing data set. Just like our vaccination program, the registration count, the vaccinees, the vaccine supply and demand keep changing from one month to another month. even weekly there are changes. So from the data we create model, and from the models we churn out information, and from there we have insights that are actionable. Let me move on with the vaccine supply modeling first. Now we started vaccination program as early as February last year. The program actually went very smoothly from the beginning to the end, even though there are some hiccups. But anyway, using advanced methods in modeling, the team could solve the problem without much difficulty. Now anyway, these are some of the challenges in vaccine supply. How many vials of vaccine to be supplied to a particular state? What type of vaccine to be supplied to a particular PPV, the vaccination center? How to model and forecast the growth rate of vaccination rate, and also the registration rate. How to optimize the PPV capacity. Now there are two main approaches. The approach one is pretty much straightforward, which is registration driven. So if you have X number of registration projected 1 month from now, then you should have X number of vials for particular set of vaccines standby and ready by then. As for approach 2, we have to look into whether or not we have sufficient PPVs at a particular location. It can be district, it can be at a state level. Now let's look at the first approach, the registration driven approach. Now vaccine distribution and PPVs to be open follow the projected registration rate. As I mentioned just now, if you have X number of projected number of registration 1 month from now, you should have enough vaccine by then. Now such projection had allowed the committee to estimate the growth rate, and from there sufficient supply can be channeled to the relevant state. Now bear in mind that there are states that are a bit slow, while there are states that are very fast. So you have to strike a balance. You have to estimate correctly at the state level and not as a Malaysian level. And the challenge here is that some states will have first dose faster than the second dose in another state, and vice versa. So you have this type of situation coming in. So in short, we do a lot of regression estimation. We forecast the registration, we forecast the vaccine information. And this is an example using the earlier data set that we got in April. So we know that, okay, this is the estimated, but of course, as I mentioned, the estimation keep changing from week to week, from one state to another. So this is just an example that I can share with you here. We base on the registration rate to actually forecast and prepare the vials of vaccine as sufficient as possible. The second approach is basically through the PPV capacity driven. Now MMU, we have Malacca campus, we have the Cyberjaya campus. Now both campuses we have PPVs, right? And these PPVs were actually had to go through a committee, approval committee, before they could be PPVs. Now, getting these PPVs could be quite difficult because we have to estimate whether or not we have sufficient supply to the PPVs and we have enough people to go into the PPV. Okay. The challenge that is different PPVs will have different capacity. That is number one. For example, in this case here, MMU PPVs is considered mega PPV. We can accommodate around 2,000 per day. As for clinic ABC, right, which is only 60 per week, while the Kerajaan clinic or the KK could be 200 per day. So you can see that different PPVs will have different count, right, different expectation. Therefore, even though unlimited vaccine supply we have and we can give to that particular PPVs, but we have a lot of constraints. We have not only the constraint in terms of the PPV setup, but we have also the number of medical officers. Do we have enough medical officers at that particular PPV for vaccination purpose? Do we have enough manpower or not? That is also a concern from the beginning. So as for the PPV capacity driven approach, it is a bottom up approach where, okay, now for this particular state, you have this number of district. So for each district, these are the PPVs that you can prepare, right? You can set up. So from there, you accumulate all the numbers, and that will be the estimated daily doses that we need to supply to that particular state. Of course, there are some added vials to the state to ensure that that particular state will have sufficient vials. Now, when I go into a more detail on the PPV capacity driven, you have two challenges. We had two challenges. Number one, how do you optimize the capacity? Right? We do not want to have oversupply of manpower. That's number one. And we sometimes one state will have more than sufficient manpower. So we want to ensure that we optimize the resources. So that therefore the optimization techniques came into picture. Right? So you see, some state will have X number of PPV type 1, right? Say for example, in this case, this particular state will have 10 units of PPV type 1, 5 units of PPV type 2, and 4 units of PPV type 4. And how do we actually optimize it so that the cost is at minimum, but the number of vaccination can be maxed up, right? So these are some of the challenges. Apart from the PPV, we have to look into the population, the behavior, the people behavior there. What sort of vaccination brand we have to make sure that this specific brand is sufficient, because we do not want the dose 1 and dose 2 to be very different. Okay, so if you have Pfizer for dose 1, you should have Pfizer for dose 2. That is the ideal case, of course. And we also have to make sure that we give priority to hotspot area, and also, of course, the vaccine storage. All right, so all these things comes into picture when we design the PPV and also the vaccine supply to that particular PPV. To ensure that everything is calculated as accurate as possible, we develop some simulation tool which is backed by AI. The first one on the left, you can see that we are estimating the number of vaccinee coming into the vaccine center per day. Right, we do a lot of Monte Carlo analysis, so we did a lot of forecasting also inside there. And on the right hand side, you have we have a map to actually monitor the cluster growth and whether or not we have sufficient PPV for that particular hotspot area. I think that's all for the knowledge sharing. Thank you again for the opportunity given to me. Thank you.